And Assalamu alaikum. Welcome to another short tutorial on the topic volume, temperature, and pressure of a gas. Here is the learning objective which is outlined in the syllabus for the chemistry O levels. I would like to introduce you to the ideal gas equation, which is PV is equal to nRT. You don't need to know about this equation at this level. You will learn about it in future classes. The reason I've mentioned here is that here are your three variables which you need to study the relationship of, that is P, V, and T, the pressure, volume, and temperature. So by this equation, we can derive these relationships by keeping these two things constant. So the relationship one becomes PV is directly proportional to T, and another one by just shifting the pressure to the other side and keeping volume over here, it becomes something like this. So these are just this, these two are the same thing, just I've shown the variables at the other sides. So for the sake of understanding, as I'm going to show you over here, so from this relationship, I've derived this one by keeping the pressure constant and taking these two variables. I've shown the relationship here. Now this applies to all the cases or to any formula that you're going to study anytime, that when you're going to see the relationship between any two variables, you keep the third variable constant. As for this case, when you are studying V and T, you're going to keep the P constant. So, so this V is directly proportional to T. And from this, I have also derived this one, that P is directly proportional to T. Pressure is directly proportional to the temperature. And from this one, I just took this, that by keeping the temperature constant, V is directly proportional to 1 over P. In other words, V is inversely proportional to P. So what do you mean by V directly proportional to T? That when temperature would increase, volume would increase. When temperature would decrease, the volume would decrease. For this case, when pressure increases, the volume decreases, and when pressure decreases, the volume increases. These are inverse relationships. And for P directly proportional to T, these are direct relationship. T increase, the P increase, the T decreases, so therefore the pressure decreases. And these three laws also occur vice versa. For instance, in this case, when pressure increases, the volume decreases. The vice versa is also true, that if volume would decrease, the pressure would increase. Now I would like to show you these on a diagram. So here are the diagrammatic representations. As you can see over here, that when the temperature is applied, so the gas particles actually gain energy and they push hard on this plunger, and they actually push it outward. So therefore the volume which was initially this much has now increased till this much. In this example, I assume that the plunger is frictionless and can easily be moved outwards. Similar is the case over here. I am assuming that this plunger or this lid is easily pushable and is frictionless. So in this case, when I increase the pressure from the top on this lid, so the gas is compressed and the particles come close together. So therefore, the volume decreases. And for this third picture, I've assumed that there is a solid stopper over here, and there is no plunger like this. It's a solid wall. So in this case, when I provide the temperature, as I've shown by the thickness of the arrows here, the pressure was less. But when the temperature increases, the particles actually gain kinetic energy. So they're striking the walls of the container with more force and also more often. That is, they also strike the walls more number of times per unit of time. So therefore, the pressure increases when the temperature increases. Now we'll be moving to a short quick MCQ on this. So here is the MCQ. You can stop the video for a minute and read it. Okay, so the question is that which statements are correct? Three statements are given. Statement number one says that the volume of a gas at constant pressure increases as the temperature increases. So you have to pay attention that which two variables are being compared in this particular statement. So one, they're talking about the volume, and the second is they're talking about the temperature. These two are being compared, and the pressure, the third variable, is being kept constant as always. Third variable is kept constant. So they are saying that when the temperature increases, the volume increases. So we have to see if this is true. As depicted by the diagram over here, when the temperature increases, the volume of the gas increased, and we also showed it over here in our this relationship. So therefore, the statement number one is correct. Statement number 2 says that when the pressure of a gas is increased, the particles move closer together. This we depicted over here in the diagram, that as we increase the pressure from the top, the particles actually move close together and the volume decreased. So therefore, statement number 2 is also correct. Number 3 says that the pressure of a gas at constant volume decreases as the temperature increases. Which two variables are being compared? One is pressure, which decreases as the temperature increases. So they are saying that when the temperature increases, the pressure would decrease. In the diagram, we saw that when the temperature increased, the pressure actually increased and did not decrease, as is written in this statement. So therefore, this third statement is wrong. Only 1 and 2 are correct. So our answer would be B. So that's it for this tutorial. Thank you.